So now what we're going to start doing is being able to graph some nonlinear functions and some linear and constant functions. What we're going to be given is some steps along the way. It kind of breaks it down nicely for us here. But ultimately, we got to be aware that there are 5 different basic functions that are coming in here. We've got a square root function, and it's a positive square root function. We've got a x squared function. You've got an absolute value of x function clicker, and then you've got this is for negative slope lines, and this is for positive slope lines, and then this is for constants. So like a y equals just a number, so constant. So 5 different ways, 5 different things that can happen for you. So have that set up so that you know which one to go moving forward, because we're going to play with all 5 of these options. Now, these are just both mx plus b forms, but what we're going to find out is that we're going to be given along the way in these examples only a single 1x or negative 1x. So we're just doing a literal negative slope line or a positive slope line. And then these will just be anytime you have a constant value, you're going to click this one, which is where we're going to start here. We have a rule that includes a constant defined to use that rule from -7 to 0. And so what we do is we click the tool that gives us a line. And then this line, a horizontal line, this constant graph, we just drag it down to -2. So you click and drag it down to -2. And then you click done. And all that means is that you put it in that done options right here. That just means you set that piece where you want it. Now what we need to do is restrict the domain to only use that line, slide that over to -7 is where we start using that rule. And then on the right-hand side, we stop using that rule when we get to the x value of 0. And then what's more is I've got to pay attention to the fact that this is a less than but not equal to. So then I come down and I click this dot to make it an open dot. And then I click the 0 to also be an open dot, a hole, because it's not including those endpoints. Now, you could have clicked done first and then click those holes, but it's best to just pay attention to it along the way, all the details as best we can. So now we've got that constant function plotted correctly using its rule. So now we're going to focus our attention on the squared right here. When you see something, parentheses squared, you're supposed to recognize that's going to be a quadratic. So that means we're going to use the quadratic tool. So we go ahead and click the quadratic icon, and you get a parabola in there. Now the parabola starts out as the parent function. This is x squared. We don't have the parent. We have a transformed. It says -2 minus 5. So we remember that whenever there's a number on the inside here, this goes left or right, opposite of the sign. And so because it's a -2, we're actually going to go to the right 2. And then on the outside, the numbers outside the parentheses goes up or down. And because it's a -5, we go the same as the sign, down 5. So we go ahead and just click and drag that vertex dot. So there's a dot right on the vertex. And we just grab it and drag this right 2 and then down 5 spaces. And once you put it at the coordinate 2, -5, you let it go. And then you say that you're done with plotting that. And we're not done restricting it. We just put it in the right spot. Now what we need to do is define the fact that this rule said that we're only supposed to use that definition from 0 to 5. So we need to restrict our domain that we use this on. Right now the arrow is saying you keep doing it. Well, what I've drawn here technically is not a function. So we got to be careful about that, because if I click submit right now, this isn't even a function because it hits a dot there and a dot there. It doesn't pass the vertical line test. So I would not be correct. So then we're going to go ahead and restrict our domain by dragging this left bound arrow over to 0, which is where this parabola is supposed to begin being the function rule. And then we end it at 5. So we drag the right bound to 5. And then both of these are supposed to be open dots because neither one of the intervals include the endpoints. So then we click finished, and that is my successful graph of this piecewise defined function of a constant piece and a quadratic piece. In the second example, we see we've got an absolute value function, and we're supposed to use that rule defined from -3 to 3. So to get the absolute value to show up, we just click the absolute value v right there, and now we have it. We don't need to transform it left or right or anything because this is the parent absolute value graph. So it's good to go, ready for us. We just need to restrict the domain. So we click done, and then we have a left bound at -3 here, and then a right bound at 3. So we go ahead and click our left bound arrow and drag it over to -3. I'm going to make that a open dot because I don't include -3. And then I'm supposed to drag the right bound over to +3. So I'm going to drag the right bound of the domain to +3, and then I click that dot. Now I have defined the function to only use the absolute value from -3 to 3. I'm done with that part. Now I'm going to move on to the second phase, which uses, I need to identify that this is a constant function and the height will be 1. So I go ahead and come over here and click the constant function again, and I need to make its height be 1. So I drag this down to 1, and now notice it's overlapping the absolute value, which is fine because I'm going to restrict the domain in a moment. So I click done with that to get the generator to allow me to restrict the domain. I need to drag the left arrow to match up with 4. So the x value of 4 is with the left bound for that constant function of 1. And then I need to finish at 9. So I come over here and grab this and finish it at 9, the right bound. Both of them are included. So this function has fully been graphed. The two pieces, one absolute value, one constant. All right, in this next example, we get another quadratic function. And this time we get our first second linear function that's not a constant. So what we're going to do is start with the quadratic. And when I click the quadratic tool, I get my parabola, and I need to drag it to the right place. This is a +5. That means I move to the left 5, and then a +2, which means I move up 2. So grab this and go to -5, 2. And that dot is my vertex. Once I have that in the right spot with the right vertex, I need to adjust the left and right bounds. It starts leftmost at -7, so I need to drag this over here to -7. And the rightmost is going to stop at -4. So I click right bound, finish that at -4, and you just have a nice little squiggle of the function. I'm supposed to have open dots on each end so that I have a nice little snippet of my parabola. And the next phase is I've got a positive slope line that's supposed to be at a y-intercept of 5. So I click done from the parabola to get my other tools to reappear, and I get my positive slope line tool out. I click that, and I use my Math 1 skills of knowing that it's supposed to cross the y-axis at 5. So I go ahead and click this and drag it up to 5 and let it go. And then I click done so that I can affect the bounds of the domain that I can use. It says I'm supposed to only use that definition from -4 on the left-hand side. So I click the left tool, drag it over to -4. And then I come over here to where the right-hand side finishes at -1. Grab that, drag it over here to -1. And then pay attention to the endpoints if they're supposed to be open or closed dots. The left one is included, so I have a solid dot here. But the right-hand dot is supposed to be unincluded, so I make that an open dot. And now I've graphed this piecewise function. So in this graph, I have a constant function of -3 and an absolute value that's translated. I haven't translated one yet. The other absolute value was just the parent function. So here we're going to start with the horizontal line, that constant function of -3. So I click the horizontal line tool, and I need to drag it down to -3. So I drag that down there to a y-intercept of -3, and now everywhere on that line is -3, but I'm only supposed to use that definition for the things that are left of -3. So left and equal to. So I click done and restrict my domain. Now it's supposed to keep going to the left, so I leave the left-hand side with the arrow. I just grab the right-hand bound and drag it over to -3, and then finish that graph, and it does have a solid dot, so I leave it. Notice it's kind of like a ray pointing off to the left, including that whole left-hand side, negative infinity to negative 3. And then I click done so that I can get my tools back and add my absolute value function to this graph. Now the absolute value function is supposed to shift. It's -4. It moves left to right opposite of the sign, just like my parabola here. So the -4 actually causes me to move to a +4 on the x-axis. I didn't go up or down, just went right 4 and drop it. And then I click done so that I can affect my domain. That absolute value graph is not supposed to be used left of 0. So I click the left bound arrow and drag that over here. So now I can include the 0. So I leave that as a solid dot. And then I'm supposed to pay attention on the right-hand side. It is bounded at 9. So I drag that right-hand side over to 9. And I can include the 9. So I leave the solid dots. And this is the completed piecewise defined function for this constant and absolute value graph on the same grid. So to finish, we will play with a square root graph. We've done all of the functions that are listed here except for the square root graph, and we get to use the negative slope tool. So here, paying attention to the fact that there are 2 lines, but this one is the negative slope tool. I actually need to click that one to get this to graph properly. So we're going to graph the negative slope tool. Click that one, and then I need it to hit the y-intercept at -6 here. So I actually need to drag it down to match up with my b value of -6. So drag it down there. Now it's in the right spot, but I only use that definition starting from 0 and then finishing at 3. So now I click done to get my boundary tools. So I drag this left bound to 0. So I see my graph is down there at 0, -6 is my first dot. And then I want to make sure I do include that one because there's an equal to. But then it's supposed to be stopping at 3. So by the time I get to 3, so I don't have to see it to do it, but I'm just going to, I don't see the line while I'm doing it, but I'm dragging this right-hand side bound over to 3. And if I scroll down, I'll notice that it did stop the graph at 3. And then it can include it, so I have a solid dot. So that's good. This is the right little snippet of that line. Finally, I have a square root function. So I'm supposed to click done to get my tools back. And the square root function looks like this. So I click the square root, and then I need it to go right 4, down 4. Remember, it's left to right opposite sign, so it's a -4. Our brain says, oh, go left, but it's actually opposite of that. Move it to the right 4 and then down 4. So right 4 and then down 4. And then once we click submit, we still have the option, or click done, we still have the option to affect the domain. But the domain is already correct. It starts at 4. The function down here, we see that 4 is our domain. It starts at 4 and then heads off to the right. So it is correct. I think if we submit, we get a green check mark, but I'm going to go ahead and slide this left-hand one over to the 4 anyway, because why not? So this is the right bounding of it. Notice again, I left the right bound, which leaves the arrow. So this is finished. This is the correct graphing of the piecewise function with a negative slope line and a square root function.